Hello viewers, good day and you are welcome back. In this particular practice problem, we are asked to answer the following. Give two examples in each of the following. I, a finite set. An infinite set. I, an equal set. So let us start with the first one, a finite set. Meanwhile, these questions, they are both questions. Please check it in the previous videos, all right? Okay, so for a finite set, what is a finite set? A finite set is a type of set whose element is finite, just like the name goes. Now we're asked to give at least two examples. Now the first example we're going to give here is rainbow color, all right? Let's say rainbow color. Now when we talk about rainbow color, the set of colors in rainbow is nothing but finite. So So we have this set of color. So these are the only color. Of course, rainbow is made up of 7 colors. So you can say set of color in rainbow. So we have the red, the orange, the yellow, the green, the blue, the indigo, and the violet. All right. So these are the 7 colors in rainbow. So it is finite. So you can say that these are the set of colors that a rainbow has. All right. So that is a good example of a finite set. Another good example of a finite set is months of the year. Months of the year. All right. Now, when you talk about months of the year, it is also a finite set because we know that there are just 12 months in a year. And we can write them out as January. Let's denote it with capital letter J, January, February, March, April, May. So we can use May for this. June, we can use J, July, Jul. Then next one is August, AU. Then September, October, November, and December. So you can see it is very much finite. There are just 12 months there in a year. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right. So a finite set, like we said, it is a set whose elements are finite. So it has limits. So now the next one on the list, which we have here, which is infinite set, is nothing but a set whose element is infinite. All right, who has infinite elements, infinite set, an infinite set. All right, so like we rightly say, we say that it is a set. I mean, an infinite set is a set whose element is infinite. So a good example of an infinite set is set of all integers. Set of all integers. So set of all integers z. So we can say that z is equal to set of now 3 dots, comma, -3, -2, -1, 0, 1, 2, 3, comma, dot, 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 and close. Now, of course, this is an infinite set. It does not end. So it started from negative infinity. That is what we mean by these 3 dots, meaning that this 3 dots is just there to account for all the negative numbers from negative infinity. All right. Then down to -3, -2, -1, 0. Then from 0 now it moves on to 1, 2, 3, then down to positive infinity. So this set of number here does not really end. So it is infinite in number. All right. So infinite, maybe set of all integers is a good example of an infinite set. Another good example of infinite set is set of all natural numbers. Set of all natural numbers. Set of all natural numbers n. All right. So set of all natural numbers n is a good example of set of an infinite set. So n is equal to 1, 2, 3, 4, and so on. All right, dot, dot, dot. That is what it means again. So now, of course, natural numbers are those numbers that ranges from 1. Natural numbers are those numbers that ranges from 1, 2, 3, 4 down to positive infinity. So natural numbers does not account for 0. It also does not account for all the negative numbers. All right. So a quick recap: set of all integers, set of all natural numbers, all these things are all infinite sets. Of course, set of all prime numbers are also example of infinite set. Set of all rational numbers, set of all irrational numbers are also example of all infinite sets. Again, set of all whole numbers is also a good example of infinite set because their elements or their members does not really end. All right, so that's it for this particular question. Now let us get to the next question I have on the list, which is this. So this particular question now says, list the elements of the following sets. All right. Now, set A is nothing but set of even numbers. Now, before I advance further, I want you to also understand that set of even numbers is also an infinite set because the element does not really end. Hence, we are going to say that set A is nothing but now they say set of all even numbers. Now they are not really specific whether it is positive even numbers or negative even numbers. So since they have just said even numbers, we are going to account or include all the even numbers, both positive and negative. So look at how we're going to represent it. We're going to say that it is dot dot dot. Then this dot 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 now will account from uh, negative infinity. They will now put -4, -2. Now, comma, we're not going to put, unless the next even number on the line is 2, 4. Now you can decide to get to 6, then dot, 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 then you now close. So this which you see here is nothing but set of all even numbers, including all the negative even numbers and all the positive even numbers. All right. Now, next up is B, set B. Set B says set of odd numbers. The same way we tackled set A, in the case of odd numbers, we have positive odd numbers and negative odd numbers. So we're going to say that B is equal set of, now we put dot, dot, dot. Now, -7, we can try to start from here, comma, -5, comma, -3, comma, -1, comma, 1, comma, -3, comma, -5, comma, sorry, plus here, then +7, dot, 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 then we close. All right. So now from here, now this -7, -5, -3, -1, they are all accounting for the negative odd numbers. And from here now, +1, +3, +5, and +7 down to plus so on and so forth is just there to account for the positive odd numbers. All right. So these are the set of all the odd numbers. All right. Now next one now is set of whole numbers. So now set C is equal to set of. Now, when you talk about whole numbers, I want you to understand that negative numbers are not regarded as whole numbers. Very, very important. Negative numbers are not regarded as whole numbers because they are just negative numbers. They are not whole numbers at all. So, and of course, 0 is a whole number. So when you talk about set of whole numbers, it is also an infinite set. So it's going to start from 0, comma, 1, comma, 2, 3, 4, 5, 6, so on and so forth, 7, 8, 9, 10, and so on and so forth. All right, so the set continues infinitely, hence an infinite set. All right, now next one now is set of prime numbers greater than 2. This is very, very important. We're talking about set of prime numbers greater than 2, and that is set D. So when you talk about set of prime numbers greater than 2, you need to understand, or maybe referring you back to what we have seen in the previous video. So this is set of prime numbers. Now, when you're talking about set of prime numbers greater than 2, it means that it is going to be all of these numbers, but you're not going to include 1 and 2. And of course, the set is not going to stop here, because it says all so what this thing actually means here now is that you're talking about just now this set D and set E, they are similar. All right, so you can even answer this particular one this way, that this is set D is equal to set of, now you're not going to include 1 and 2 since it says greater than 2, so you're going to come from here and say you're going to start from 3 actually, since they said set of all the prime numbers that is greater than 2. So 1 and 2 is not going to be among, but you're going to start from 3, 5, 7, 11, 12, no, so 13, I mean to say 13, 17, 19, 23, and so on. All right, so because the list does not end, unlike in this case now this particular one now you see is actually set of prime number. This one now is actually a finite set, because the condition says that it is actually prime numbers between 0 and 100, so there is a limit, so it is finite. So but this particular one you see here is actually infinite. All right, it does not end. Very, very important we understand that it does not actually end. So this particular one now does not actually end, it is infinite. Now, what about this particular one you see here? This one now says set of prime numbers. Now, this one now is different from, now set E is different from set D that we've seen, because set E is just there to tell us to write out all the set of prime numbers. All right, this one now is a typical case of infinite set. So the only difference between this and this is that in this case now, we are going to include 1 and 2, but here we are not going to include 1 and 2. We are not including 1 and 2 here, but we are including 1 and 2 here. So set E is equal to set 1, 2, 3, 5, 7, 11, 13, 17, 19, 23, and so on and so forth. All right, dot dot dot, meaning that it continues. All right, so this is set of all prime numbers. Don't forget what prime numbers are. Prime numbers are those numbers that can only be divided by themselves and 1 only. All right, so any number that can only be divided by 1 and itself is a prime number. Very, very important. So that's it for this particular video. Do well to subscribe to my YouTube channel. Click on like, comments. Don't forget to keep put your observation in the comment section below. We are going to be looking forward to answering them. So please do well to take down your notes. Very important. Thank you.